do a confidence interval to estimate a population mean. And there are two situations that you guys have to consider. One situation is whether or not sigma is known, and the other is whether sigma is unknown. I said that if sigma is known, sigma is the population standard deviation. If it is known, then I'm going to use a critical value of z of alpha over 2. And your margin of error actually is not this one. Your margin of error is, if you want to use your margin of error, is calculated as z of alpha over 2 times sigma over the square root of n. Obviously not a huge change between the two formulas, just the critical value and sigma. But S is sample standard deviation and sigma is population standard deviation. If sigma is unknown, then your margin of error becomes, this notation. So a critical t-score, and you have S, which is a sample standard deviation. Now you guys are interested in the calculator trick, okay? The calculator trick kind of basically, it tells you exactly what you want. If you pull up, where's my calculator? Your calculator. Where did we find one prop z int, right? We went to tests, and we scrolled down under, all the test stuff. So I want interval stuff. So what do I think I'm going to use here? If sigma is known, I'm using z-scores. So I'm going to use z-interval for my calculator trick. If sigma is unknown, I need critical t-scores, then I use t-interval for my calculator trick. So these are the calculator tricks. Corresponding to these two situations. Now you're going to have to decipher when it's, z and when it's t, when sigma is known and when sigma is unknown. Sometimes it's directly given to you and sometimes it is not. You have to, read between the lines in a sense. Now, okay, let's just assume this wasn't here. So I have, again, a lot of word problems now when you get into these chapters of statistics, confidence intervals and hypothesis testing. But this is a very important part of statistics. Use 15 birth weights of girls, given an example too, whatever. 15 birth weights of girls. My sample size is 15, for which n is 15 and x bar. So they give me x bar. I need to interpret that. That is the mean of the sample size. Okay, that is the mean weight of these 15 girls, okay? So, if it's not directly given in notation, it will be given in words, and you have to create notation. So you need to go back and forth between the words versus the notation, the variables, okay? Construct a 95% confidence interval estimate. My confidence level is 95%, which means alpha is 1 minus 0.95 or 0.05. All of this is literally from like the first, line and a half? Construct a 95% confidence interval estimate. Now, don't forget also that you're going to have a combination of different confidence intervals. Construct a 95% confidence interval estimate of the mean birth weight. I want a confidence interval for mu, where mu is your mean birth weight of all girls of the population, assuming that sigma, okay, sigma is known now. Sigma is known to be 2.9 Hg. Okay, so I'm going to read it again, look at the information that I gathered, and then figure out what method I should use. Use the same 15 birth weights of girls, sample size is 15, such that their sample mean is 30.9. Construct a 95% confidence interval, that gives me alpha, of the mean birth weight. I want a confidence interval for a mean, a population mean, in this case where it represents a mean birth weight, by assuming that sigma, sigma is known to be 2.9. Sigma is known, right? Oh, sorry, 1 second. I'm plugging my thing in. So I got to go, first of all, okay, I want a confidence interval for a mean, right? Not a proportion, a mean. So I'm going to use t-interval or z-interval. Well, which one do I use? Am I on a z-score, z critical values, or t critical values? Sigma is known. If sigma is known, what do I use? I use Z. I'm going to go Z interval, right? Using my calculator trick, okay? Z interval. So let's go now to the calculator and see. Okay, so we're just going to straight up find it, and then we're going to interpret it. Where do you find Z interval? Right? I said we're going to stats, tests. All this stuff is found in the same place. You don't want to run a test. You want an interval. You need to scroll down past test and go to interval and stuff. I want Z interval, which on mine is number 7. Enter. This information is wanted. Now, you have a lot of situations that you are asked for. You either have data or stats. Do I have data? Do I have a list of numbers? No, I'm given stats. So let's go over to stats. Scroll over and press enter. So that now stats is highlighted. And you'll see that now they're asking for the stuff that we have. Notice that under Z interval, they ask for sigma. You'll see when I use T interval, it'll ask for S because I don't know sigma. Kind of tells you what you should use and when. Okay, sigma we said was 2.9. X bar, I forgot that one. What was that? 30.9. My sample size, N, was given to be 15. I want a 95% confidence level. Calculate. Here's my confidence interval from 29.43 to 32.36. So let me write that down. Again, don't forget, we're going to interpret it also. 29.4. So how do they represent? They rounded to the nearest 10? So we'll round to the nearest 10th also. So mu, remember that this is given on the calculator in a interval notation. So this is the low end of my interval, 29.4. 29.4 Hg for my units is the low end, and the high end is 32.4 rounded to the nearest 10th Hg. So this is the confidence interval, the 95% confidence interval estimate for the mean birth weight of all girls from this sample. So that is the confidence interval for that situation. But now I'm not done. Let's interpret it. Now you're going to get used to this interpretation because you're going to write the same stuff over and over and over again. It's just going to change depending on what the heck interval you found. Why the heck did I do that? We are.
What did you press on the calculator again to get that? Second what?
We're going to go through that again in the next example. We are 95% confident that the, where do I get the rest of this? Mean birth weight of, I'm going to literally copy that. The mean birth weight of all girls is between 29.4 Hg and 32.4 Hg. Done.